Okay, here is lesson 7.3. What we're talking today about is volumes. We're going to take shapes and we're going to find the volume of that. First of all, what we've got here, the volume is going to be the integral of the area times the thickness. Now, right here, this is going to be the thickness. Our dx is going to represent the thickness. Now, take a look at this little thing that I drew here. It's a very thin cylinder. This right here is its thickness. We're going to call that dx. This right here is its area. Okay, so if you take the area and multiply it by its thickness, you're going to get the volume. That's what we're going to do. Let's go do a problem on this, okay? Here we go. Here's our first one right here. Okay, and what I have is I want to find the volume of a solid that's bounded by these three graphs. Now, I drew already the graph y equals square root of x. How about where is the graph x equals 4? Yeah, it's right here. There's x equals 4. Where's the graph of y equals 0? Yeah, that's just the x-axis. So take a look at that. Take a look at that area, and what we're going to do with that area, we're going to revolve it around the x-axis. We will always revolve around the x-axis. Now, I'm going to try and sketch it in for you. Here we go. It's going to go here, here, a little bit there. Okay, here we go. Okay. Now, take a look at that one area. I'm going to revolve it around the x-axis. What I'm going to end up with here is a shape like that. Okay, there. In the back, I'll put, there you go. Are you seeing it now? It's a solid, a round solid. Now, one of these cuts right here, let's just do this one. There's our thin cylinder. I'm going to start my cuts right here at x equals 0, okay? And I'm going to slice it all the way to x equals 4. Okay, now here's the shape. You're trying to say, what does it look like? Yeah, here it is. Do you see that shape going around like that? It's making a solid. It's flat on the right side, and it kind of comes to a little bit of a point on the left. So here we go. Let's go ahead and do our volume. Now, volume is the integral of area. Well, first of all, where do we start our slices? We're going to start at x equals 0. Where do we finish our slices? At x equals 4. Now, what type of cross section? When I slice this, what do I get? What's the area? Yeah, it's a circle. So it's going to be pi r squared and then dx. Now, what's the radius? What is the radius? Right here, there's the radius. What is the radius equal to? Well, the radius is equal to the y. Because, see, it goes up in the y direction. Yeah, but what is the y equal to? Oh, the y is equal to square root of x. So, yeah, the radius is the square root of x. Let's go ahead and plug it in. Okay, here we go. Volume is, we're going to start our slices at 0, go to 4. Okay, now it's pi, it's r squared. But what are we going to plug in place of r? Yeah, the square root of x. There it is. There it is. Look at that. Pi r squared. And in place of the r is the square root of x. Okay, let's keep on going with our integral. Here we go. Volume equals. First of all, the pi. The pi is a constant. we're going to bring that constant out front. Now 0 to 4. Now, what is the square root of x squared? The square root of x times the square root of x is just x. There you go. I think we could do the antiderivative. Here we go. We got pi. Okay, tell me, what is the antiderivative of just x? What function, when you do its derivative, you get just x? Yeah, it's going to be an x squared, and I think we're going to have a 1/2 out front. There it is. That's the antiderivative. Straight evaluation bar 0 to 4. Okay, let's figure this out. Here we go. We got volume is pi. We leave the pi till the very end. Let's plug in the 4 first. We got 1/2. We got 4 squared minus plug in 0. You got 0. There we go. Hey, let's see what we got. We got pi. We got 4 squared is 16. 16 times 1/2 is 8. 8 minus 0 is just 8. Here it is. Let's do 8 times pi. Okay, our answer, 8 pi. There it is, 2513. 2513. There's our volume. Okay. Again, we always start our problems like this. Okay, it's going to be the integral of pi r squared. The limits will change depending on the problem, but that's how you start it. Then you plug in place of the r, you plug the y. And in this particular problem, the y was square root of x. So we plugged in place of the r, square root of x. We simplified it, the square root of x squared, just x. Great, we pulled the pi out front, and then we just did our integral. There we go. Okay, looking good. Let's go to number 2. Okay, on this one, here we go. It says, find the volume of a solid made by revolving the region around the x-axis. Oh, look at this. This is a little different. Use the calculator this time to solve our integral. Okay, so first of all, the squiggly line, that is 2 plus sine of x. Where is x equals 0? That's right here. Where is x equals 2 pi? That's right here. Where is y equals 0? I think you know that. That's right here. That's the x-axis. So look at that region. We're going to revolve it around the x-axis, okay? I'm going to try and sketch in the picture, okay? Here you go. It's going to go to here. It's going to go to here. It's going to go here. And then it's going to go back to here. So it's going to start right here. Okay, here it is. There it is. Okay. Now, take a look. Make this. Okay, now remember, I'm taking that region and I'm revolving it around the x-axis. So I'm going to get a shape something like this. There, it's going to be circular. If I do a cross-section, here we go. I'll do a cross-section right here. There it is. Oh yeah, the cross-section is a circle. There it is. Take a look. There's my little cylinder that we talked about earlier. Okay, let's start it off then. Volume is the integral. Where are we going to start our cuts? Yeah, at x equals 0. Where are we going to finish? At 2 pi, at 6.28. We'll put 2 pi. Okay, good. Now, remember, it's always going to be pi r squared and then dx. Okay, here we go. 0 to 2 pi. What is our radius? Well, our radius is right here. There's the radius right there. Yeah, but that's equal to y. Well, what's the y equal to? Ah, there it is. 2 plus sine of x. So that's what's going in for the radius. So here it is. Let's do that. We've got 2 plus sine of x, quantity squared, then dx. Nice. Now, Notice what it said up here in the yellow. Use your calculator on this one to solve the integral. So let's go do that, okay? Here it is. Okay, let's go to our calculator. We got pi and then 2 plus sine of x quantity squared, okay? Let's go take a look. So we've got, clear this out. First of all, check our mode. We are in radians, that's good. Okay, we go math, number 9. Okay, where did we start the slices? At 0. Where did we finish? At 2 pi. Good. Now, it was pi r squared. So we got a pi. Now, remember, the r was 2 plus sine of x. So 2 plus sine of x. Close that. Close that. Now, it was 2 plus sine of x is the r, and the r is squared. So there it is. Now, take a look at what I'm doing. I'm putting parentheses around the 2 plus sine of x, and that parentheses is being squared because the r was squared. It's pi r squared. Now let's go over here, put an x. There it is. Everything's set up. We got the integral from the limits, 0 to 2 pi, pi r squared. In place of the r is 2 plus sine of x. Let's press enter. There it is, 88, 83. Let's go with that. 88, 83. There it is. That's our volume. Notice on that one, here's the shape here again. Okay, we'll move that up so you could see it. Yeah, there it is. Okay. Take a look at that. See, you're doing the slices from 0, and you're slicing right here, right here. You're slicing, and you're slicing all the way to x equals 2 pi. Okay, and that whole volume is 88, 83. Let's double, yep, that's what I had last time. Okay, looking good. That's the end of part 1. We have one more problem in part 2. So go ahead and find part 2 of lesson 7.3.